Welcome to the another session in Frontiers in CFD. So CFD simulation of flow past a heated 2D cylinder with heat flux, and simulation is done with ANSYS Fluent. The objective is to create and mesh a 2D cylinder geometry for CFD analysis to simulate the flow and heat transfer using velocity and heat flux boundary conditions to visualize velocity, temperature and flow patterns with post processing. So welcome. Today we will see the CFD simulation for a fluid which is taking place over a cylinder, a horizontal cylinder. So for this we will prepare the 2D geometry, and how this analysis can be done with the help of 2D geometry, that we will see. So we need to prepare sketches, and we need to create surface from sketch, and then we have to proceed for meshing and the other part. So let's start with the fluid flow fluent option. I first go with the geometry part, so I click on new design modular geometry. So first of all, set the units. Say I set centimeter, then click on any one of the plane. You can see X is red, Y is green and Z is your blue. So the same is appearing here. Now I will prepare a sketch. So just click on sketch option here, go to the sketching and click on rectangular. So I have prepared one rectangle. Let's give the specifications for this. I put it X as 150, Y I will put 250. So I prepare a rectangle of dimension 150 by 50. Now I need one more circle on this sketch. So I will make first surface from the sketch here. So go to the concepts, select surface from sketch, make it apply and make it add to frozen and then generate. So now you can see a surface has been prepared from the sketch. Now on this sketch itself I will prepare one more circle at somewhere around the center. So let's specify the diameter, say around 25. Dimensions of this we will specify from one end, say here I will take it at the center, say for example 75. Similarly from this to the center I will specify the dimension that is equal to 25 here. So now I will make it generate. So now you can see this is a surface and you are having a circle which has been drawn here. Now accordingly we will proceed for the remaining part. So you can see it is surface body. Now especially when we are considering the 2D modeling, so 2D modeling is quite better if you want to reduce the number of nodes and element, because in 3D you will be having more numbers of nodes and element. At the same time you depend on the computational capabilities we are having. So 2D can be done quite easily. So we'll proceed with the 2D's example today. So same can be done in 3D as well. So let's go and click on edit. So we need to generate mesh. So in 2D it gives some advantage in terms of taking more number of nodes and element in that particular visualization. So now this is the object which we have generated. So let's first generate the default mesh and see how the mesh has been generated. Now this is the mesh. Right now the count is around 184 or something. I will just reduce the element size to, let us say, 0.005 and let's make it generate. So generate the mesh. So we are making it refine. You can see now the mesh has been generated here. So if you see the count, 28,729. If you want, you can make it further fine as well. So let us take 0.0025. So in 3D model, you have to consider many things as a complete geometry, and that's why the mesh count becomes slightly a difficult thing to handle, because if the mesh count goes higher, at the same time the computational capabilities also we need to take into consideration. So with the 2D, we can consider a particular phase, and on that particular phase we can do the analysis. So I have taken the element size now 0.0025. So with this element size, we'll just check it out how fine the mesh is, and accordingly we'll proceed for the next step. So this may take some time. So you can see now the mesh has been generated. So if you see the count, 1,13,820, 1,12,874. So this is the mesh count which is available right now. So let's define some things, like here I'll select the edge here. I will specify this as inlet. So create name selection, I put it as inlet. Similarly, I select this end, I put it create name selection, I will put as outlet. And this one I will select heated surface. So I have defined three boundary conditions. One is inlet, on that we say edge, similarly outlet, and this is one heated surface. So let's make it update. So once it is updated, you will see the mesh translation to Fluent successful. So if this window appears, you can actually proceed for the next step. So I just close meshing part. Okay, so if you want to save the work, so let's save the work. So flow fast 2D cylinder. So this is the name I have given. So let's move to the next part, that is for your setup. So number of processes I will put somewhere around 16. So double precision. Now here you can see it is by default it is showing 2D option. If you have generated the object in 3D, it could have shown 3D. So here we will define the models which we want to use. We'll use this very general model in order to proceed for this simulation, to make it more simple. So once the object is loaded, you will see inlet and outlet with the help of arrows. So specify transient model, then specify gravity, that is minus 9.81 here. So I selected transient model, specify gravity. Now go to the models, turn the energy equation on. So next is we will put viscous here, K epsilon, enhanced wall treatment, thermal effect and curvature correction. Let's make it okay. Next we'll go to the materials. We'll keep the material default as it is. We can use some other material as well, like water or some other working fluid. So cell zone condition I don't need to change, as over here you can just see here. Boundary condition I will put some velocity. So let's put 0.0025 meter per second, or let us say 0.001 meter per second. Make it apply and then close. So heated surface I will apply boundary condition. So let's go to the heat flux, let us say around 600 watt per meter square. Make it apply and then close. Go to the reference values. Tell the computer from where to start. I will say inlet. Reference zone I will take surface body, and let's make it go to the report definition. Here I will go to the surface report, area weighted average. I will specify temperature. Here I will specify the total temperature. I want total temperature at outlet, so I will write the report definition accordingly. So total temperature outlet, report definition 0. So let's make it okay. Then close this. Go to the initialization, click on initialize. Then go to calculation activities. If you are running the simulation for a long time, it will be always better option to autosave. Then go with the solution animation. In solution animation, select the animation which we want to visualize. So let us say temperature. Here I will select total temperature. Go to color map option. Here to avoid exponential scale, I make it float. Make it apply, then close. Click on save display. You can see the object will be loaded. Now here I will specify total temperature animation. Make it apply. Now you just go to the run calculation and start doing the calculations. So put some value, let us say around 10 for the first 10 run. We'll visualize what changes are occurring in the animation window as well as on your screen. So you can see the temperature curve is going up. Gradually you must also visualize some variations in temperature in terms of the fluid which is been present here. So we'll run this simulation for some long time and then we'll visualize what actually the changes are occurring inside the fluid zone. So you can see the variations of temperature. So you can see variations of temperature. You can see the temperature at outlet curve. So this is will represents the temperature of the fluid that is changing with respect to time. So simulation is complete. You can see here. So right now we are run around 110 as a flow time. So I will run this further for few more 200, and then we'll check how the results will come out. So as of now the curve is not getting flat, still it's on the verge of rising. So we'll run it for some more time and then we'll visualize how the simulation goes. You can see the calculation is complete. So the curve is likely to get flat, but it hasn't been yet. But we can run it for further some time. So let's say we run it for 100 again and just visualize what happens. So the total flow time is around 300 seconds as of now. You can see 323. So we'll run it further to check what further subsequent changes occurs, whether the curve will get flat or not. And then we'll run it the post processor to visualize how the simulation with the particles moving from one end to other end. So this is your contours of total temperature of the system. This is your total temperature at outlet of the system. We can use some different working fluid as well, like we have used only the air as a working fluid. We can use some different working fluid and we can check how things changes with respect to the different working fluid. So we'll wait till this calculation is completed. Calculation is completed. Now you can see this is contours of total temperature. Again the curve is not completely flat, but we'll just visualize the post processor. So just click on result and edit. Once you click on result and edit, the post processor will open. So let's click on inlet, outlet, symmetry 1, symmetry 2 and wall surface body. So I will make all of them transparent one. So let's specify transparency 0.95 here for all of the cases. Let us say symmetry here 0.95, make it apply. Here also make it 0.95, make it apply. And lastly at outlet make it 0.95, that is transparency here. And lastly inlet also specify the transparency, that is 0.95. So you can either remove the wireframe model as well and you can visualize the object. So first of all I will set volume rendering. So I will select the parameter as a temperature and I will select the local temperature here. So specify somewhat higher resolution, let us say around 150. So this will which represents the temperature volume rendering for the object. So this may take some time. So this may take some time. You can take lower resolution as well, so as to reduce the time which has been required. So 50% has been completed. Now you will see temperature volume rendering here. So you can see now this temperature volume rendering. I will just put it on one side so as to visualize it in more better way. So I will change the scale here. Default legend view, I will put it at the center. I will change the size of this to make it better visible. Instead of scientific, I will put it fixed, and I will increase the value tricks here. So you can see the count is also changed here. Now so let's add the temperature streamline as well. So I click on temperature streamline, start from inlet. In variables you have to select temperature now, not velocity. So range I will take it local, make it apply. So now you will see a temperature streamline that will be visible here. So with this streamline, now we'll just visualize the simulation. Let's take the sweep animation, take it streamline. In options, you can actually reduce the number of particles which are been available. So go to the option, size of the particle I will reduce. So symbol size, you can see I take it less than this one, and let's click on play option, and you will see the particles are coming. So here, so while the particles while moving, they will take heat from the cylindrical object, and then they will proceed ahead. So you can define more number of particles as well. So here I have specified around 25, but more can also be specified. So once they are in touch, in contact with the cylindrical portion, you will see some rise in the temperature for these particles. So yeah, consider less number of particles, that is around 25. So you can see now how they will move ahead. You can see some rise in the temperature of the particles when they are moving. So the temperature you can see has increased. Now it is. Now this simulation will run till the time all the particles which are present inside will go outside through inlet. So you can have more number of particles as well to visualize it in more better way. So instead of 25, you can make it 50 or so, and that will be better to visualize. So you can see another layers of particles are coming now. Once all of them are pass this through outlet, you can see the simulation will stop. You can save the simulation as well in terms of number of in terms of video file, as it can be a 4K video file, 2K video file. So I'll just show you how this can be done once this passed the end of the geometry, that is at outlet. So they can see, you can see they are disappearing from the outlet. So till the last one remains, you will see the simulation will stop. Okay, so the last one is left. Once this is passed, you can see this will stop. Okay, so you can see it has been stopped. Now, as I said earlier, you can have more number of particles as well. So I will put it somewhere around 50. Then again, remaining parameter will keep it as it is. Now for saving the video, I will just show you one option. You have the save movie option available. So go here. I will say select flow past 2D cylinder. Keep on save. Go to the option here. Ball size, I will make it slightly on the lower side. Let's say around 0.48. Then here I will select custom option 3840 and 2160, that is for your 4K. Go to the advanced setting, save the file. I will save the directory as same as the one which I have selected. Now the frame rate I will take it higher, then highest I will select and make it OK. Now once you click on this, you have to just check this one here, streamline, and you will click on this. Now this process will start. If you go back to your desktop documents, and this is the folder where the files will start getting created. So you can see one by one the particles are coming. So there will be such more number of frames which will be generated once you can see this process which has been here. And with that particular process, you will see around 1000 images will be generated, and at the end of 1000 images, the file will also be saved as a video file. So that's it. We will just complete the simulation and then we'll visualize how it will be there. So this represents the temperature streamline when the fluid enters and when the fluid is leaving. So in the next slide, we'll see the video of that. So this represents the outlet temperature with respect to the flow time. How the outlet temperature of the system changes with respect to time. It has been shown with the help of this graph.